Hello and welcome to Section 3 of our course. We've completed our setup and gotten a taste of running our first script. Now, we move on to the fundamental building blocks of all programming languages. Data types. What are data types? In simple terms, a data type is a classification that specifies which type of value a variable has and what kind of mathematical, relational, or logical operations can be applied to it. Think of it like a container that not only holds something but also dictates what you can do with what's inside. When you write a program, you work with different kinds of information: numbers, text, dates, true, false values, and more complex collections of data. Python needs to know what kind of information it's dealing with to store and manipulate it correctly. Section 3 Overview. In this section, we will cover the simple, fundamental data types before diving into the complex sequence types later in the course. Here is a quick look at what we'll master. Numeric Types, Lecture 3.2 and 3.3. This includes whole numbers, integers, numbers with decimal points, floats, and special numeric forms like complex numbers. Boolean Types, Lecture 3.4. These are the simplest type, representing just two values, true or false. They are essential for flow control and decision-making in code. We will also learn how to change data from one type to another using type conversion functions and discuss the rules for naming variables, known as identifiers. Understanding data types is non-negotiable. If you try to perform a mathematical operation on text, Python will throw an error. A strong grasp of these types will save you countless headaches as you build more complex programs. We'll kick off the core content of this section immediately in our next lecture, 3.2. Numeric Types, where we'll explore integers and floating point numbers in depth. I'll see you there. Welcome back. In our study of data types, we are starting with the most common and fundamental type, numeric types. These types are used to store numbers, whether they are whole numbers or numbers with decimal points. Python has three primary numeric types, but we'll focus on the two: int for integers and float for floating point numbers. Let's jump into VS Code and see these in action. 1. The integer type int. An integer, or int, is a whole number, positive or negative, without a decimal point. One helpful built-in function we can use to confirm the type of any variable is the type function. Let's print the type of our student count variable. See how Python confirms that student count is of class int. A powerful feature of Python is that its integers have unlimited size. They can grow as large as your computer's memory allows, which is a major difference from many other programming languages that have size limits on their integer types. 2. The floating point type, float. A floating point number, or float, is a number, positive or negative, that contains a fractional part, typically represented with a single decimal point. Let's check the type of temperature. This confirms the type is float. Notice the last example, bank_balance equals 1000.00. Even though the value is technically a whole number, the presence of the decimal point, .00, makes Python treat it as a float. 3. Basic arithmetic. You can perform all standard arithmetic operations on these numbers. Notice something important here. Even though 7 and 2 are integers, the division operator always produces a float result in Python. If you specifically want the whole number part of the division, you use the floor division operator, 2/. This operator throws away the decimal part, giving you an int result. So, to summarize, int for whole numbers, which are unlimited in size, and float for decimals. Keep them straight as they form the foundation for all quantitative work in Python. Our next lecture, 3.3, Complex, Binary, and Hexadecimal Types. I'll see you there. Welcome back. In our last lecture, we covered the standard numeric types, integers and floating point numbers. Today, we're going to explore some of Python's more specialized numeric types and representations, complex numbers, and the use of binary and hexadecimal formats. One. Complex numbers. Complex. A complex number is a number that comprises a real part and an imaginary part. In mathematics, the imaginary part is represented by I. In Python, we use j to denote the imaginary part. Here, 5 is the real part and 3j is the imaginary part. Python uses the complex data type to store and perform mathematical operations on these numbers, which is particularly useful in electrical engineering and scientific computing. 2. Binary, octal, and hexadecimal representations. While Python stores all numbers internally in binary, base 2, we usually work with them in decimal, base 10. However, Python allows us to represent numbers using other bases directly in our code. This is common when dealing with low-level systems, security, and memory addresses. Binary representation, base 2. To write a number in binary format, we prefix the digits with 0b. The number 0b1010 is interpreted by Python as the decimal number 10. The 0b simply tells Python how to read the digits that follow. Hexadecimal representation, base 16. To write a number in hexadecimal format, we prefix the digits with 0x. Hexadecimal uses digits 0 to 9 and letters A to F to represent values up to 15. The number 0xa is also interpreted as the decimal number 10. Note that Python also supports octal base 8 using the 0 prefix, but it is much less common than binary and hex. We go to built-in conversion functions. Python provides simple functions to convert between these formats. The bin function returns the binary string representation. The hex function returns the hexadecimal string representation. The int function can convert a string in any base back to a decimal integer. To summarize, Python handles specialized numbers like complex using j. For low-level representation, you can use the 0b prefix for binary and 0x for hexadecimal. Now that we've finished with the numeric types, we move on to one of the simplest yet most vital data types for programming logic, the Boolean type. I'll see you in lecture 3.4. Welcome back. We've spent time covering the different ways Python handles numbers. Now, we are moving on to the simplest, yet arguably the most powerful data type in all of programming, the Boolean type. A Boolean value, or bool type in Python, represents one of only two possible states, true or false. These values are the foundation of decision-making and flow control in every computer program. In Python, these two values must start with a capital letter, true and false. Remember, if you type true with a lowercase t, Python will treat it as an undefined variable, not a Boolean value. You rarely create a Boolean value directly like we just did. Instead, they are generated automatically when you use relational operators, which are operators that compare two values. Let's see some examples of how these comparisons work. Every time you use a relational operator, Python evaluates the statement and returns a Boolean, either true or false. 3. The power of Booleans, flow control. The real power of Booleans comes when we use them to control the flow of our program. This is done primarily with the if statement we introduced earlier. Because the comparison user age is greater than or equal to 18 evaluates to false, the code executes the else block. Booleans are the literal gatekeepers of your code. To summarize, the Boolean type is the simplest but most essential data type, representing the two possible logical states. It is created using comparison operators and is used to drive every decision in your program. In our next lecture, 3.5, Type Conversion Functions, we will learn how to manually change data from one type to another, like converting a number into text, or vice versa. See you then. Welcome back. We've seen several Python data types. But what if you have data of one type, like a number, and you need to treat it as a different type, like text? This is where type conversion functions come in. This ability to explicitly change a data type is called typecasting. In many programs, especially when taking input from a user, data comes in as a string, but you need to convert it to a number to do math. This is a critical skill. The int function is used to convert a value into an integer. It's important to note, when converting a float to an int, Python doesn't round. It simply truncates the decimal part. Also, if you try to convert a string that contains a decimal or non-numeric characters, Python will raise a value error. 2. Converting to float. The float function converts a value into a floating point number. This is useful if you need to ensure a number is treated with decimal precision for future calculations. 3. Converting to string. The street function is essential for converting any value, be it numbers, booleans, or something else, into text. This is most often needed when you want to concatenate or join a number with other text. Once the number 30 is converted to a string 30, we can safely join it with other text. 4. Converting to Boolean. The bool function converts a value into its Boolean equivalent. The rule is very simple. 0 and empty values are converted to false. Non-zero and non-empty values are converted to true. This understanding of truthiness is very powerful for writing concise if statements. To summarize, Python provides built-in functions like int, float, str, and bool for explicit type conversion, allowing you to manipulate your data correctly. That covers our type conversion functions. In our next lecture, 3.6, Identifiers, see you there.
Welcome back. In this final lecture of our data type section, we are going to cover the essential rules for naming variables, functions, classes, and other objects in Python. These names are collectively called identifiers. Choosing good, descriptive names is a hallmark of a good developer, but first, you must know the strict rules Python enforces. 1. The strict rules. There are 4 non-negotiable rules for creating an identifier in Python. If you break these rules, your code will fail with a syntax error. Rule 1. Start with a letter or underscore. An identifier must start with a letter, capital A to capital Z or lowercase a to lowercase c, or an underscore. It cannot start with a number. Rule 2. Cannot contain special characters. An identifier can only contain letters, numbers, and the underscore. You cannot use spaces, dashes, exclamation points, or any other special characters. Rule 3. Case-sensitive. Python is completely case-sensitive. This means that identifiers with the same spelling but different capitalization are treated as entirely separate names. Rule 4. Cannot be a Python keyword. You cannot use any of Python's reserved keywords, like if, for, while, print, class, def, true, false, etc. as an identifier. These words already have special meaning to the Python interpreter. If you try to use a keyword, Python will raise a syntax error. Two, style convention, PEP 8. While the first 4 points were mandatory, the final point is a convention recommended by PEP 8, which is Python Style Guide. It's important for readability. For variables and function names, the widely accepted standard is snake case. All lowercase letters, with words separated by underscores. Mastering these rules ensures you don't run into annoying syntax errors, and following the style guide makes your code is readable and professional. This concludes our section on data types. We covered numbers, Booleans, and how to name them. Next up, we move to a new section, Section 4, Sequence Types. I'll see you in Lecture 4.1.